So moving forward, let's consider question number 4. Alpha beta are the roots of equation x square plus px plus 2 and the reciprocal 1 by alpha 1 by beta are the roots of equation 2x square plus 2qx plus 1 equals 0. Question is find the value of this expression. Now when you look at this equation which has roots alpha beta and another one which has roots 1 by alpha 1 by beta. If I ask find the equation whose roots are reciprocal to the roots of this equation, what that would be? Clearly that equation would be 2x square plus px plus 1 is equal to 0. Because what we do, we replace x by 1 by x. Now it is given to me this equation is 2x square plus 2qx plus 1 equals 0. Clearly we have a relation p equals 2q. This is one important relation given to me. If required, we will use it further. Now moving forward, we have to simplify this expression. When you multiply, let's say this expression is a. So when you multiply, what you will be getting? Alpha beta minus alpha by beta minus beta by alpha plus 1 by alpha beta multiplied with alpha beta plus 1 plus 1 plus 1 by alpha beta. Now the product alpha beta, when you see at the given equation, you can say it is 2. From any of the equation, you will get the same product as 2. So this is 2 plus 1 by 2 minus alpha square plus beta square upon 2 multiplied with 2 plus 1 plus 1 plus 1 by 2. So this is equal to 5 minus alpha square plus beta square whole divided by 2, so keep half outside, into this is 4.5, that is 9 by 2. So I'm sure things are clear till this point. Let's rearrange. This is 9 by 4 multiplied with 5 minus alpha plus beta whole square minus 2 alpha beta. Correct? Alpha plus beta given to me minus p. If required, we can also use in terms of q, but let's start with minus p term. So this is 9 by 4 multiplied with 5 minus p square plus 4, or simply 9 by 4 into 9 minus p square. Let's check out from the given options whether we need to continue in p or need to change in q. 9 by 4 into 9 minus p square, that is, it is given to me as option number 4, so that's the required choice. So let's mark and mention as the required result. So I'm sure this is also clear. Let's consider the next one. The value of this one, where up to 51 terms given, in the second series again up to 51 terms given, is equal to. Let's see what the question is talking about. When you talk about any expression like n plus 1 into n p n minus 1. You can say this is n plus 1 into factorial n. So this is n plus 1 factorial. Now it's quite simple. Therefore, if I consider this entire sum is equal to s, 2 into 1 p naught, it will be simply 2 factorial minus 3 factorial plus 4 factorial and so on up to 51 terms. Is this clear? What would be the 51st term? That is clearly plus 52 factorial. Next, plus second one, simple 1 factorial minus 2 factorial plus 3 factorial and so on, plus last term would be 51 factorial over here. So when you see what you can find here, 2 factorial, 3 factorial, every term is cancelled. So this is 52 factorial plus 1. Now look at the given options now. 52 factorial plus 1 is the required result, which is given here as option number 2. So let's mark and mention it as the required result. So I'm sure this question is clear. Time to move on to the next one now. Integral minus pi to pi mod of pi minus mod x dx is equal to. Let's try out this question. I equals, when you replace x with minus x, This internal term is unchanged. That means it is even. When it is even, so you can write it twice of 0 to pi mod pi minus mod x dx. Now when it is 0 to pi, clearly mod x is x. Now when it is 0 to pi, pi minus x, its modulus is also same. So yes, it is 2 times 0 to pi, pi minus x dx. Integrate it. This is twice of pi x minus x square by 2, 0 to pi. Put this value, you get pi square minus pi square by 2, that is pi square by 2 into 2, giving you the result as pi square. Let's check out from the given options. Pi square, that is option number 1, is the correct answer. So mark and mention as the required one. Moving on to the next one, that is question number 7. Let's see what it says. Let, this denotes the greatest integer 1, obviously it is. So the question is talking about lambda, unknown term involved, and it is saying limit x approaching to 0, mod of this term is L. Then find this limiting value L. Let's try this question. Limit x approaching to 0, mod of 1 minus x plus mod x upon lambda minus x plus greatest integer of x is equal to L. Now clearly we can see that we need to go for LHL and RHL. When we go for LHL, this is limit h approaching to 0, modulus of 1 minus, instead of x we write 0 minus h, so it is plus h because mod of minus h is simply h, divided by lambda plus h minus 1. So when you apply limit, you observe it is mod of 1 upon lambda minus 1, or simply 1 upon mod lambda minus 1. Now when you go for RHL, this is limit h approaching to 0, modulus of 1 minus h plus h upon lambda minus h plus 0. Applying limit, this is 1 upon mod lambda. Since the limit of the function exists and is equal to L, we have 1 upon mod lambda is equal to 1 upon mod lambda minus 1, or mod lambda is equal to mod lambda minus 1. Eliminating modulus, we get lambda is equal to half. So the value of lambda is half. So what will be the value of L? Clearly L is 2, because here we have 1 upon mod lambda. So lambda is half, giving you value for L is 2. Let's check out from the given options. 2 is given here as option number 1. So let's mark and mention as the required result. I'm sure this question is also clear. Time to take up the next one, that is question number 8.